So today we're going to go through the different shapes of the molecules that we did in the last video. So first of all, you have to have these Lewis dot diagrams drawn because the dots, the lone pairs that are around the outside of the central atom are going to affect the shape of it. The first one is only 2 atoms, and a lot of people get confused with this because they say, oh, it's got dots on the F, that's going to make it bent or bend it down or something, but if you only have 2 atoms, all you can really do is just draw a straight line between them. We can add some electron clouds, so you can see those electron clouds, but the electron clouds, you can't see them as part of the shape, and so because there's no central atom here, it's not going to affect the shape. So notice that it's just linear, it's just straight across. All you can do is just draw a straight line if you just have 2 atoms. And technically there's no bond angle because you have to have 3 points for a bond angle, and there's only 2 here. And this also goes for the nitrogen. Let's take these off. So the N2, it's just 2 atoms next to each other. The triple bond does not affect the shape, so that's just going to be linear straight across. All right, let's go down to the NH3 that we have in red. So I'm going to add 3 atoms and an electron cloud. So what I want you to notice is that the electron cloud is pushing away from those hydrogens. Let me take it off and then put it back on again. Notice that when there's no electron cloud there, that they're flat. That's called trigonal planar. Tri because you have 3 outside atoms, and planar because it's all in the same plane. So if I turn this molecule so that it's flat, you can see that they're all going to be flat on the table. These bond angles are going to be 120 degrees. Turn it this way so you can see. Because it's a third of a circle. So it's a perfect triangle, circle is 360, so a third of that would be 120. If I add an electron cloud though, notice that, let me take it off, so they're flat here. Watch the electron cloud as I add it, watch the silver atoms and watch how they move away from that cloud. No matter where it sticks on there, they're going to move away from that cloud, and that's because of electron repulsion. So that cloud is pushing those silver atoms down, and that's what makes it into a pyramid. So this one is called trigonal because there are 3 outside atoms, but it's a pyramid this time instead of being planar. And the bond angles for this one says 109.5, but you're going to learn in AP chemistry it's actually closer to 107, and that's because the electron cloud is pushing just a little bit harder than if it was an atom. So if I had 4 atoms, that would be 109.5 degrees. That's a tetrahedral shape. But that cloud is pushing just a little bit harder than an atom, and so it squeezes them down just a little bit more and makes the bond angle just a little bit smaller. So that one is trigonal pyramid. All right, our next one is CH4. So we have 4 outside atoms, and again, notice that it makes kind of a pyramid shape with one sticking straight up, and the bond angles for that are 109.5. Be careful, because a lot of people try to draw it like a square, and they would say that these bond angles right here are 90 degrees. And 90 degrees is not as far away from each other as 109.5, and the whole point of this is that the atoms on the outside are trying to get as far away from each other as possible because they all have electrons that are repelling each other. So they're going to push away from each other as far away as they can. And 109.5 is a farther bond angle than 90 degrees, so it does not make a square. All right, our next one is the NO. That's just 2 atoms next to each other. We can move on to the CO3. So this one has a double bond to the oxygen, to one of the oxygens, and then single bonds to the other 2 oxygens, and notice that it makes a trigonal planar shape. So it's totally flat, bond angles are a perfect 120 degrees, and notice that that double bond does not affect the bond shape. So things that do affect the shape are dots on the central atom, electrons on the central atom, but the double and triple bonds don't affect the shape. All right, let's move on to PCl5. So we did most of these shapes in first year chemistry. We did linear, we did trigonal planar, we did tetrahedral, trigonal pyramid, and bent. Let me just show you a bent real quick. If we have 2 outside atoms and then we stick another pair on there, notice that it pushes them down and takes them into a bent shape. And the bond angle is going to depend on how many clouds you have. So if you only have 1 cloud, it's similar to trigonal planar. If I add another cloud, now it's similar to tetrahedral, so it's going to be closer to 109.5. And because you have 2 electron clouds here, remember they push harder than atoms, so they're actually going to squeeze those together closer to 104.5. But this simulation is rounding it to 109.5 just for simplicity. So let's go back to our PCl5. This is going to be the first of our new shapes. So we never did more than 4 outside atoms in first year chemistry, and this time we're going to do as many as 6. So first let me go ahead and show you, if you have 5 outside atoms, this is the shape that it makes. So notice that you have straight up and down in the middle is like a middle axis, and then around the middle axis is like a belt, a triangle belt. So notice that it's 90 degrees from the top to the middle belt, or from the bottom to the middle belt, but the bond angles around the middle are actually 120 degrees. And I'll show you some 3D models in class when we go to class 2. Let me try to turn it so you can see it better. Okay, there we go. So that belt in the middle is going to be it's like a trigonal planar in the middle and then a top and a bottom. So we have several bond angles here, like I said, 90 from the top to the middle or from the bottom to the middle, and then it's 120 around the middle from those atoms from one to the other. And again, this one is only showing the 90 degrees because the simulation doesn't go quite to AP chemistry level. This is called trigonal bipyramidal. So trigonal because you have 3 outside atoms around the belt, and then it's a bipyramid because it's like you have a pyramid going up and a pyramid going down. If you connected all those lines, it would kind of look like, let's see if I can draw it over here. So you have one straight up, you have one straight down, and then around the middle you have this triangle here. And so if you connected those dots, it would make a pyramid shape. You can't see it from there, but it would be a pyramid shape. So it's called trigonal bipyramid, and that's our first of the new shapes. So the shape for PCl5 would be trigonal bipyramid. If we exchange one of those atoms for a cloud, the first place you're going to put the cloud is on the belt. So notice that it went to the middle of that. And this one is called let's see if I can turn it so you can see it. It's called seesaw. Can't quite get it. So let's see if I can do it. So you see how this kind of makes a seesaw. I can't really make the seesaw. I'll make it happen. Again, I can show you much better in class once we do a live session, but it's called a seesaw shape. You can kind of see it right there with the straight line and then the bond angle where it would be a seesaw. If you add a second cloud, it's going to continue to put it on the middle belt. So you always put them on the middle first. This one is called, let's see if I can turn it for you. Whoops, we have too many clouds now. Or too many atoms. There we go. So 3 atoms and 2 clouds. So we still have 5 total outside things. So notice that the electron geometry in the bottom left corner says trigonal bipyramid. That is including the electrons as if they were atoms. So the overall geometry is the electron geometry. The molecule is if you ignore the electron clouds. So they're still there pushing on the other atoms, but you can't really see them because they're just regions of negative charge. And so now you can see that it's going to be a T shape. It looks like a T. All right, and then let's exchange one more for a cloud. And you can see that now it's going to be a totally straight line. So now we're back to linear because the belt around the middle is all electron clouds. And again, we're going to go into more detail with some of these shapes in our next couple of lessons as well. So let me just review trigonal bipyramid real quick. So we have a central atom, we have a top and a bottom, and then around the middle we have this triangle. And so the bond angles from these triangles, all these over here, are going to be 120, and the bond angles on the top and the bottom would be 90 degrees. If we exchange one of those atoms for a cloud, the first place the cloud is going to go is the belt, and so now it's a seesaw. You see if I turned this page sideways, it would look like a seesaw where you have it like this. So that's called seesaw. If we exchange another atom for a cloud, now it's going to look like a T. So if you turn it sideways, you get the letter T. And then if we exchange another one for a cloud, again, it's going to go to the belt. So now all we have are clouds around the belt, and so if you just go straight down from top to bottom, it's going to be linear. All right, and then our last type of shape is if we have 6 total atoms. So let me take off these. 2, 3, 4, 5, 6, or 6 total outside atoms. And this one is a very symmetrical shape. So it's 90 degrees all the way around. From every single silver atom to the one closest to it is going to be 90 degrees. And this is called octahedral. And you may be saying, well, why are they using the prefix octa? Because that means 8 when we're really talking about 6 outside atoms. And that's because we're talking about the different planes. So if you divide this into different planes, like you did geometry, there are 8 different regions here, 4 on the top and 4 on the bottom. So this one is called octahedral, and I think, let's see, where's our work over here? So this would be some, we're going to work up towards this ICl4 in just a few minutes. So if you have all 6 outside atoms, it's octahedral. Let's exchange one of those for an electron cloud. And notice that the cloud, I always put it on the top first. So for trigonal bipyramid, you're going to put the clouds around the middle belt. For octahedral, you're going to put the clouds on the top and the bottom first. So when you put a cloud there, notice that the molecular geometry is now called a square pyramid. I can flip it upside down. There we go. So you have a square base and then one sticking straight up. So that's called a square pyramid. The electron geometry is the overall geometry. So again, that's including the electron cloud as if it was part of the shape. But then since we can't really see the electron clouds, it's just that region of negativity, it becomes a square pyramid. If we take off another atom and add another electron cloud, see that it goes opposite of the bottom electron cloud. So now we have what we call square planar, because you see how that square of atoms is all in the same plane. And again, you always put the electron clouds on the top and the bottom for octahedral. And then if we add another one, it's going back to the T shape. So notice this looks similar to the last one where you've got the letter T. Turn it all the way around. There we go. And then if you take off another one, and now it's back to linear. So now we have electron clouds all the way around. So we're going to practice a whole lot with these molecules, but let's go back to that ICl4 to see if we can determine what that one was. So we have 4 atoms and we have 2 clouds. And so you can see if you put it like this, 4 atoms and 2 clouds is going to give you square planar. So those 2 clouds are going to be on the top and the bottom. You're going to get a perfect square in the middle with 90-degree bond angles. And that's it for the different types of shapes. But like I said, we'll go through these in class just a little bit because I know it's kind of hard to visualize them. So I have some models that I can show you so you can see the 3D images.